Good day everyone. So for this video, we are going to learn about homogeneous differential equations. But before we go into that, let's learn first what is the meaning of homogeneous. We're going to learn how to determine homogeneous polynomials and homogeneous functions. So homogeneous polynomials are actually polynomials whose terms are of the same degree. So examples of these are the following. We have, let's say, x squared minus 3xy plus 4y squared. So as you can see here, we have three terms in the given polynomial. The degree of each term is 2. So 2, summation of the exponents here of the two variables is 2, and also for the third term is 2. Another example of that would be x cubed plus y cubed, or we have x to the power of 4y plus 7y to the power of 5, or x cubed minus 3x squared y plus 5xy squared minus y cubed, or you can have x to the power of 4 minus 2x squared y squared plus y to the power of 4, or even have 2x minus 5y. So all of these here are examples, all 6 of these polynomials here are examples of homogeneous polynomials because all the terms in the given polynomial are of the same degree. So for the first polynomial, the degree is 2. For the second, it's 3. For the third one, it's 5. Again, for the fourth one, it's still 3. The summation of the exponents here of the variables are this all the same. Number 5, it's the degree is 4 here. And on the sixth one, we have first degree polynomial. Now, if we talk about functions, a function f of xy is homogeneous of the nth degree if it can be written such that f of kx, ky is equal to k to the power of n f of xy. Meaning, if we substitute the x's and y's in the given function with kx and ky, and by algebraic manipulation, we can write this into the form k to the power of n f of xy, meaning we're able to factor out this constant here raised to a certain exponent n, then we can say that the given function is homogeneous whose degree is this exponent here n. For example, we are given the polynomial, function f of xy is equal to x squared minus 3xy plus 4y squared. So we want to check if it's homogeneous and to what degree. So we are going to substitute all x's and y's with kx, ky. So substituting, that would now be kx quantity squared minus 3 kx ky plus 4 ky quantity squared. So by algebraic manipulation, this is k squared x squared minus 3k squared xy plus 4k squared y squared. And as you can see here, all the terms here, common in all of them is k squared. So we can factor out k squared. And when we factor out k squared, we have x squared minus 3xy plus 4y squared left inside the parentheses. And as you can see, this is just equal to f of xy. Meaning, our conclusion is that the given function f of xy, because we were able to write it in this form, is homogeneous. So we say f of xy equals x squared minus 3xy plus 4y squared. So the given function is a homogeneous function of degree, what's the degree? It's the second of degree 2. Okay, let's have another one. For example, we are given now the function. We want to check if it's homogeneous or not. The given function f of xy is equal to x all over the square root of x squared plus y squared. So using that method, we want to check if it's homogeneous or not. Then we're going to substitute all x's and y's with kx, ky. So that would be now kx over the square root of kx quantity squared plus ky quantity squared. So by algebraic manipulation, this is now kx over the square root of k squared x squared plus k squared y squared. And factoring out the common constant k squared, we have x squared plus y squared. And extracting the square root of k squared here, that would be k. So kx over k square root of x squared plus y squared. And remember that when we divide, what do we do with their exponents? We subtract. So the exponent of k becomes 0. So k to the power of 0 times x over square root of x squared plus y squared. So because we were able to write the given function in this form, k to the power of n f of xy, then our conclusion is that the given function f of xy equals x over square root of x squared plus y squared is a homogeneous function, of degree, what's the degree? Degree 0. So that's how we determine the homogeneity of a function. Another thing is that we can determine the homogeneity of a function f of xy by replacing x and y with another variable. So usually the variable that we use is the variable u, so that it will form cu to the power of n. That's cu to the power of n, where n is the degree of the polynomial. So instead of replacing with, just like this one here, instead of replacing with kx, ky, what we're going to do is to replace x and y with a single variable. So like for example, we're given the function f of xy equals x cubed plus y cubed. So this time, instead of kx, ky, we are going to replace again x and y with u. So this will now become f of u equals u cubed plus u cubed. And that would now be equal to 2u cubed. So in this example, our c is 2 and u raised to the power of n. So we can say, because we are able to write it in this form, then our conclusion is that the given function f of xy equals x cubed plus y cubed is a homogeneous function. It's a homogeneous function of degree, what is the degree of this function? Of degree 3. So it's this one. Okay, another one. We want to determine if this given function is homogeneous. F of xy equals square root of 2x minus y. So replacing x and y with u, f of u is now equal to the square root of 2u minus u. And that would now be equal to the square root of u. Or f of u is equal to u raised to the power of 1/2. So in this form, we were still able to write it in the form cu to the power of n, where c is simply equal to 1 and the exponent n is 1/2. So our conclusion, that the given function f of xy equals square root of 2x minus y is a homogeneous function of degree, what is the degree? Of degree 1/2. Okay? Okay, how about another one? The given function f of xy equals square root of x plus 2y squared. So replacing with u, we have f of u equals the square root of u plus 2u squared. And so since we cannot combine u here, we cannot write it in this form, then we can say that this given function is not a homogeneous function. Now, even if we use the other method, if we like substitute f of kx, ky, okay, replacing x and y here with kx and ky, this would now be kx plus 2 ky quantity squared. And so this would now be kx plus 2 k squared y squared. So square root of, we are going to factor out k, we have x plus 2 ky squared. And so we'll have square root of k, or k raised to the power of 1/2, square root of x plus 2k y squared. So since we are not able to write it in the form, remember, f of kx, ky is equal to k to the power of n f of xy. And so k is not totally isolated because we still have k here under the radical sign. So our conclusion is that the function f of xy equals square root of x plus 2y squared is not a homogeneous function. Okay,